Hello, everyone, and welcome to today's ELOQUENCE Webcafé. It's great to see you all here, and thank you all for joining us. Today's topic is teaching AI Europe's languages, which is really at the heart of what we do here in ELOQUENCE. ELOQUENCE is pioneering the development of advanced voice and chatbot technologies aimed at transforming unstructured dialogues into comprehensible, safe, and unbiased interactions. Our focus is on creating self-learning adaptable models for diverse languages and use cases, emphasizing sustainability and European values, especially in safety-critical applications. And I'm very happy to be joined by Seraphina Fong and Lorenzo Concina, who bring complementary perspectives from speech technologies, linguistics, and user-centered research. So we can start with some brief introductions. Maybe Seraphina, you can start. Could you briefly introduce yourself, your background, and your role in ELOQUENCE project?
Sure, thank you so much. So I'm Seraphina. I am a second-year PhD student in computer science at the University of Trento in Italy, and also within the speech tech lab at FBK. I have an interdisciplinary background that spans cognitive science and computational linguistics, where my current PhD focuses on speech and language processing, multilinguality, and inclusivity. So I currently work on investigating how to make speech LLMs more inclusive, robust, and generalizable to better handle, let's say, real-world linguistic as well as task diversity. And lastly, while today's webcafe focuses predominantly on European languages and multilingualism, I should mention that although I'm not European, I'm originally from Singapore, which is also very multilingual, and that has also strongly shaped my perspective on language and communication in general.
Okay, thank you. Lorenzo, your turn.
Thank you, Elena. Thank you, Serafina. My name is Lorenzo Concina. I'm a researcher at Fondazione Bruno Kessler in Trento. I'm working actually with Serafina in the same team, the speech tech team. And my work focuses mainly on extending large language models to the audio domain. Within two European projects, ELOQUENCE and also IMI. Talking about ELOQUENCE, I'm mainly involved in work package 4, which is about multilinguality and adaptation of speech models. Previously, I served as a machine learning specialist at the World Intellectual Property Organization, which is a specialized organization of United Nations based in Geneva. And there I took part of the development of speech technologies, including training and deploying ASR models that now transcribe UN conferences in Geneva. So that's pretty much it. So thank you again, Elena, for inviting me today. And I'm excited to share the outcome of my work here.
Thank you, Lorenzo. Let's start with a broad question. From your perspectives, what does it actually take to teach AI a language or even a dialect in a way that truly reflects linguistic diversity rather than just a standardized version of a language?
Yeah, so I'll answer first and then Lorenzo can pick up afterwards. So I think for me personally, teaching AI different languages or dialects is essentially like helping it grow around a lot of different speakers and not just handing it a single dictionary for it to learn from. So I think ultimately there's different ingredients to this recipe of learning. So first of all, like us humans, it needs exposure. So AI needs to learn from experience, which means large amounts of real, very varied and diverse data. So when it hears things like slang, regional dialects, regional expressions, disfluencies, and everyday variation, I think it helps it learn that there's not only one single correct or one standard way to speak. Second, I think that context is super important. So the meaning of the words that we use within a sentence depends on who's speaking, what situation, and for what purpose. So to handle this kind of linguistic diversity, I think AI has to encounter the language usage across different social, cultural, and also emotional settings. And lastly, in my opinion, it also requires a lot of representation and care. So, for example, if certain communities or speaking styles or dialects are missing or even underrepresented within the training data, the system can learn to struggle to understand them. And so it's super important to ensure that there is balance and also representative data. So this includes diverse voices and also actively checking for any biases. Yeah, and so this will help build systems that are more understanding of linguistic diversity.
Yeah, thank you, Seraphina. So I'll try to complete, this answer with my point of view, which actually has an overlap with yours. So I think, to try to understand linguistic diversity, there are several pillars, critical pillars that we must consider. So I'll start from the acoustic variability that you just briefly mentioned. So, diversity also means understanding not native accents, or for example, different age groups, or again, maybe you mentioned later, but also different health condition of the speaker, and also all these different characteristics, they alter the audio signal that then um, the the AI model process. Also, another important point is the resource gap. So the difference, let's say the massive difference between high resource languages and low resource languages or dialects, again, for which data is scarce. Then another point that I think you mentioned before, Seraphina, but again, is the domain specificity. In the sense that, real world communications and conversation, they don't happen, let's say, in a vacuum, but there's always like specific terminology. Whether it's I don't know, a technical patent discussion at the World Intellectual Property Organization, or I don't know, a medical consultation in the ELOQUENCE pilot. In any case, models, they must know domain specific terminology to really, understand diversity. And I think that the last point I'd like to mention is continuous learning, which means that, languages are not static, but they evolve, and the same way the software does, including AI models. So we really need to keep model updates by train them continuously on new data, which is actually what I am, currently exploring in this field.
Thank you. Thank you both. One thing I find really interesting about both of you is that your backgrounds are quite different. So, how does this interdisciplinary combination strengthen multilingual speech technologies in practice?
Sure. So I think that with my background predominantly being in linguistics and cognitive science, I've mostly focused on understanding how humans learn, produce, and also understand speech. So learning that variability shouldn't be considered, let's say, an edge case, but a norm. And also that things such as accents or dialects or multilingualism, for instance, are essential features of the language that we speak and not really noise that should be removed. So I think that when this viewpoint is combined with ASR and also engineering expertise like that from Lorenzo, I think that the impact is quite strong. So linguistics can help us identify the richness and the variability that comes with real speech, real language, and engineering at the same time can focus on turning that understanding into more practical and scalable systems that work reliably in real world settings. Yeah, so I think like me and Lorenzo working together, this interdisciplinariness really helps enable multilingual speech technologies that are more robust and human-centered. But yeah, that's my opinion.
Yeah, thanks, Serafina. So I take the chance to make some marketing actually with questions. So at FPK, Serafina and I collaborate on speech LLM research, as you mentioned already. So we conduct experiments on existing pipelines to develop multilingual and multitask models. And by combining our expertise, we already successfully trained a multilingual linear projector that is able to extend LLM to the audio modality for 28 European languages. And we released this model that we call Musely on Hugging Face, and we also submitted a paper for ICASP 2026. At the same time, we're also trying to pack this model and making it available in the Eloquence playground for the future pilots of the project. We're also exploring how to further improve this multilingual projector through a technique called continual learning, in order to extend this model to even more languages. Right now, it supports, as I mentioned, 28 languages, but we are exploring continual learning to add more low resource languages. Yeah, that's it.
Thank you. So you mentioned audio modality. Seraphina, could you maybe briefly explain what it means to extend LLM into the audio modality and why this is especially important in multilingual European context?
Sure. So Lorenzo had briefly touched upon this just now. So essentially extending LLMs into the audio modality is what we sometimes refer to as speech LLMs, or you may also see it as LLM-based speech processing. So these models are essentially designed to directly process spoken language instead of operating only on text, which is what a typical LLM would do. And so at the same time, while directly processing spoken language, it can simultaneously leverage the kind of rich textual knowledge or linguistic knowledge that LLMs have. And so while traditional speech systems would usually follow a more cascaded approach, where first usually the speech is converted into text, and then this text is subsequently fed into a separate language model, speech LLMs can help unify these steps by jointly learning the audio and the language at the same time. And I think this makes it possible to reuse and also adapt the strengths of large pre-trained models and simultaneously grounding them in speech. I do have to say that although labeled speech remains essential, labeled speech data rather, the usage of pre-trained models within speech LLM frameworks allows this data to be used more effectively. And so with that in mind, I think that this is particularly valuable for multilingual Europe because these large pre-trained models provide basically a foundation that can be adapted across many languages that we have here in Europe, including those with limited resources. So I think that it enables us to leverage cross-lingual knowledge and also transfer, and allows us a more scalable and flexible path towards multilingual speech technologies here to support Europe's linguistic diversity.
Thank you. Maybe Lorenzo, could you give us from a more linguistic and user-centric standpoint, which aspects of real-world speech or communication do you often see missing from existing data sets?
Sure, Irene. Yeah, thank you for the question. So, yeah, while thinking about this matter, I really tried to thought about the challenges that I found in the past while training these speech models. So, yeah, I think we all agree that data nowadays is the fuel of modern AI. I mean, for everything, like from the speech model's point of view, but for any other model. And theoretically, we should have as much data as possible that matches the data distribution of the audio or speech that the model sees in production at inference time, right? So, but at the same time, there's also a trade-off between, let's say, quality, quantity, and the availability of other resources that we need to train the speech models. So, at least in my experience, I try to do the best with the data available, which could be either open source or proprietary data. And for what I saw, specifically at the UN, proprietary data usually cover with much more details the specific domain we care about. So just an example at WIPO, we are recordings and transcription of UN conferences, which contained the terminology we needed. So acronyms, proper names, specific words, which was extremely useful. But at the same time, this data is not validated by a big community, and so they may contain errors that impact the training process. While on the other hand, open source data are usually bigger, these datasets are bigger and better curated, but with minimal or non-domain knowledge. So it's really necessary to mix the two to get the best from both worlds, and in order to optimize the results and performances. So one last point I'd like to mention on this matter is that datasets may be speech dataset or audio datasets may contain audio recorded in different environmental settings with respect to the ones that the model will see in production. So depending by the specific use case, we should pick up the correct dataset to train our speech models. Yeah.
Okay, thank you. I think both of you could answer the next question. So which aspects of this linguistic richness do you feel are still most underrepresented in today's AI systems? And more broadly, what truly makes a speech or language technology inclusive? Is it mainly about the data, evaluation practices, or something else?
I think for me personally, some of the most underrepresented aspects are non-standard varieties, but this coming in the form of pathological, impaired, or even disfluent speech, where disfluent speech can be even speech that contains stuttering, hesitations, or filler words such as which I tend to use a lot. And I think that these are like really real and common ways that people communicate in everyday life. But I think that AI systems are often trained and evaluated solely on standard or, let's say, typical speech. So I think that personally, inclusive speech and language technology isn't just about adding more data, although the data is crucial, but it depends also on how this data is selected, labeled, and then evaluated. So one of the big takeaways that I have is that inclusive systems should treat this variability as more of a norm as opposed to an error. And they should also be evaluated on whether they work well across different speakers and communities and not just kind of an average standard performance. The last point that I have is that I think that it's also super important to have community involvement to ensure that the people who are most underrepresented within these technologies can help shape how the data is collected and also used.
Thank you.
Yeah, on my side, thank you, Seraphina. So on my side, I may add a few words about those challenges that are maybe underrepresented in speech systems. So first, I already mentioned it before, the challenge of dialects. So and I can mention a very concrete example from my own country, Italy, where each region has a slightly different dialect, which in some cases is a completely different language for historical reasons. So this influences the way people speak Italian, and this is not always taken in account in speech models, of course, because they are trained with the standard data of that specific language. And this challenge, we can find a parallel issue of this challenge, which is non-native speakers talking a second or third language, like me right now with English, or when I do speak French. And a concrete example of this is I saw it at the UN, because there, even if speech models, they're required to only handle 6 languages, because there are only 6 official languages at the UN. So in each and every conference, you can hear only the 6 languages. But there are people from every part of the world, which means that you may hear those languages with a lot of different accents. And those speech models, they really need to be robust, towards this challenge. And yeah, maybe the last problem I want to mention here is how we evaluate this model. So we usually compute the word error rate and character error rate to evaluate ASR models, so very specific kind of speech processing models. But this may not be enough in those cases I just mentioned. So we may want to instead evaluate these models deeper by trying to understand where are the error patterns in the transcription, or really considering, deletion error, insertion errors to understand where the problem is while translating these, dialects or non-native speakers.
Thank you. So you mentioned working for United Nations agencies, which is quite impressive. Are there any specific lessons from that experience that strongly influence how you approach ASR research today?
Yeah, absolutely. So I learned a lot there, and I faced some issues that I mentioned in the previous question. But so about the lessons I learned, first, we really need to have training data that properly cover the distribution in the speech that is transcribed by the model when deployed in the real case scenario. So this I already mentioned before, but this is I really want to stress this because open source models that we tried to transcribe UN, even if they were very good on public benchmarks, then they failed in transcribe specific terminology, specific acronyms, or of course proper names that they never heard about. So with the specific example of the UN, their ministries and diplomats talk about international affairs and intellectual property, at least at WIPO. So again, models, they really need to be aware of this terminology. So you need to either train them from scratch or fine-tune them on proprietary data. And this leads to a second point that, a second lesson that I took with me in my current job, which is ASR errors, they have different weights in the sense that, and this is not reflected by word error rate and character error rate, for which each and every error has the same weight. So, some words, if mistaken, are much worse than others. And we are talking about, those words that belong to the specific domain we care about. So we really need to retrain models periodically. And the period, it depends by the use case. So in that case, for the UN, I think it was around every year. But this depends because the data distribution change. So the data that the models see in production changes. Maybe there are new words, new terminology, new conferences, new people coming to the conference. So all these things, they must be taken in account. And again, word rate and character rate are not enough to monitor the performance of the models in a multilingual scenario where there are a lot of non-native speakers. So the goal is to optimize those metrics, but also to understand where the error patterns are in the transcriptions. Yeah, I think those were the main lessons I got.
Thank you. So back to you, Seraphina. What are some common misconceptions people tend to have about speech, multilinguality, or language technologies that you often encounter?
Sure. Yeah, that's a great question. So there's a few that I have in mind. So the first one being that I think that there's a common misconception that a single approach to speech technology can work equally well for everybody in a kind of one size fits all type of way. But in reality, speech and multilinguality can vary widely across languages and dialects, or even speakers and contexts. So these systems that are often optimized for solely clean or carefully recorded speech can perform poorly when in more real world conditions, let's say. The second assumption or misconception is I think that some people have the tendency to think that there's a single or neutral correct way to speak a language, and that variation is just noise or error. But from a linguistic perspective, this variation is very normal and meaningful. Moreover, a lot of multilingual speakers and may even mix languages through code switching within one sentence. They can also shift styles and also adapt to different contexts. So the way in which we talk here may be very different to the way in which we talk to our parents or even between friends. And so this often challenges these kind of rigid or overly standardized system designs. And lastly, I think that some people often also assume that these language technologies interpret speech or language in a kind of human-like way. But in reality, these systems often just learn statistical patterns from the data rather than meaning in a more cognitive linguistic sense, let's say. Mm-hmm.
Nice, thank you. Lorenzo, what would you say are currently the biggest technical challenges when working with low resource or underrepresented languages?
Yeah, so on this topic we're really touching several topics that we mentioned before, but to stress them again. So the biggest problem is definitely the scarcity of the training and validation data for certain languages. So the one that we define, that we call low resource languages. So and why do we define like this? Well, because there's data for these languages, at least for most of them, but at the same time, technology has advanced in the past years, specifically AI and deep learning, and models, they became data eager in the sense that they want more and more data to be trained. And since research has been done mainly with main languages like English or nowadays Chinese too, of course, many other languages were left behind in the sense that the amount of data is not comparable with the main ones. And that's why we call them low resource languages, because the trained techniques that we apply, for example, again for English, they may not be applied for those other languages because the amount of data is way lower. At the same time, another challenge is actually the ability to carry research on these languages for really, and these are personal challenges. I'm just making an example, a concrete example. Actually, at WIPO, I had to fine tune, as I mentioned, ASR models for the 6 official UN languages, which are English, French, Spanish, Chinese, Russian, and Arabic. And I could, I got the best results in terms of performances and evaluation on languages that I could understand and evaluate, which are English, French, and Spanish. While for the others, unfortunately, especially for Chinese and Russian, I struggled much more. And one reason was that, again, I couldn't evaluate the outcome of the model, the output of the model. And also, in that specific case, I didn't have anyone who could help me in, better understanding the output and run those analyses that we talked about before, especially with Russian. So since there were less people in that specific context speaking those languages, it was a bit more complex to address them. Yeah.
Okay, thank you. I have one more question for you. It's my final question. So, if you imagine the ideal future of multilingual AI in Europe, say 10 years from now, what would you hope to see become possible?
So maybe this time I can start, Seraphina,
Mm-hmm.
for the last one.
You seem excited.
Actually, this was, I think, the most complex matter you brought to the table, because since I'm a quite younger researcher, I mainly saw, let's say, the transformer period in natural language processing, speech, and LLM. So in practice, then in theory, I also studied other architecture and stuff, but in practice, I'm mainly focused on the transformer architecture still. So to me, it's a bit hard to forecast the future and how it will evolve, but probably what we see right now is that research is heading to try to get a universal model, and with universal model I mean something that is multilingual first, but also multitask, and that it can switch from one thing to the other shameless and without issues. Yeah, so and that's also actually what we are trying to do at FBK, to extend to as many languages as possible, as well as to as many tasks as possible. So yeah, probably that is the direction. Who knows?
Yeah, I think for me, I'll just add a little bit to that. So in line with having more language support, I'd hope to see more coverage for under-resourced languages or low-resource languages like Lorenzo had been talking about, so that technology can help us sustain this linguistic diversity as opposed to flattening it. And aside from this, I also hope that it would be more inclusive by design. So evaluating on real speakers, diverse speakers, being adaptable to different individuals and the way in which we speak, and also developed in collaboration with the communities. Yeah.
Okay. Thank you both. Are there any questions from our audience? You can type them in the chat box, or you can just raise your hand or whatever. No. Okay. Is there something you, Seraphina and Lorenzo, would like to add?
It's actually mainly a question, Helena. So are we going to share this webinar later on our channels, or is it going to be private here?
Yes, it will be on our YouTube channel, and I will post it on our website. So yeah, okay. If there aren't any questions from the audience, I would like to thank you both, Serafina and Lorenzo, for sharing your insights and for having this little chat with me. And I would like to give big thank you to everyone who joined us today. For those who'd like to stay connected, you can find more about Eloquence on our website and social media channels. And yeah, the recording will be on our YouTube page. So make sure to like, share, and subscribe. And yeah, thanks again, and enjoy the rest of your day.
Thank you so much. It was a pleasure. Thank you.
Thank you.
Thank you very much, Helena. Thank you to all. Bye-bye. Have a nice day.
Thank you. Bye.
Thank you.